Hey everyone, in this video I want to dive into template specs and how they can really make your life far easier when you think about, well, how can I actually do my deployment with JSON ARM templates. As always, if this is useful, please go ahead and give this video a like, subscribe, comment and share. My goal is not to go into what is an ARM template. I've got other videos, you can go and check out the links that talk through what is an ARM template. But fundamentally with an ARM template, we have this JSON-based document that is declarative. I'm stating my desired end state, and the job of the Azure Resource Manager is to take that desired end state that I define in my JSON template and make it so. So we have our target environment that is Azure. And when I basically deploy the ARM template, the Azure Resource Manager looks at, well, what's the desired end state in the file? What's there today? Let's make that so. So it's idempotent. I can deploy as many times as I want. If the desired state matches the file, nothing happens. If it doesn't match, well, then it's going to make it so. So that's the point of a JSON file. And they're phenomenal. Now, there are some pain points with JSON. Some people find it very verbose. It's hard to create. That's why there are technologies like Bicep now. So with Bicep, I can actually write my desired state in a different language, and then it compiles into an ARM JSON file. But that's a different video, Bicep. So we have this file, and there are challenges. There are challenges, well, how do I actually make it available so end users can leverage it? Now, one solution I might do is, for example, we have a repository. So we have some kind of typically Git-based repository, and I can check in my template into that repo. So the benefit here is I can have different versions of that template. But to use it, what people have to do is essentially clone the repository, and then they get their own copy of it, and hopefully they keep it up to date. Maybe what I have is kind of a pipeline. I have the idea of I have my kind of CI/CD pipeline, and that will connect to the repo. It will check it out so it has a copy of the files, then it can deploy my resources. But just for general people to want to be able to consume that template, it's really not the easiest thing in the world. So I want a better way to make them available so people can actually use them. Also, this is just a basic template. If I start linking to other templates, it gets even harder. Because if I want to link, and I'll show this later on, if I want to link to another template, I can't just link to a local reference. I have to have some publicly accessible point because I only send this template to the Azure Resource Manager. It then has to be able to reference whatever I link to, so it has to be a shared access signature to a blob, which I have to create and manage, or it has to be publicly available. Something like GitHub, I can access the raw point to the GitHub file and use it that way. So there are challenges kind of with the use of these various things. So what template specs do is really change the way we can think about having a template available. And what it's going to do is it's a new type of resource. It's a first-class Azure resource. And now we can actually create this template spec. Now with this template spec, it has versions. It has full role-based access control. So straight away now, it has role-based access control. It's a resource in Azure. So for any other user to be able to actually deploy it, all those users need in this RBAC is read. So if I have read permission as a user to the template, I can now reference the object and deploy it. So it makes it far easier. It has versions. Because it's just an object now in Azure, it's easy to reference from anywhere else. And I can use these anywhere I could normally use a template. be it the portal, be it PowerShell, be it CLI, be it my pipeline, I can now reference these template specs and actually use them. But they're now easy to stage because this is private. It's not just publicly available. So it's this private capability that I don't have to worry about the storage behind the scenes. So it's easy to now share with potentially different teams. And I can still pass it parameters and everything else. Now, this doesn't mean I don't use, for example, Bicep. I can still absolutely use Bicep to create the JSON file that I then store as a template spec. Because again, inside the template spec is the JSON, the ARM template. It doesn't mean I don't still use repos. Today, I think about I might have my application, I have my source code in a repo. I then build to have a certain release. Well, I could have my ARM file still in change control. And then when I get to a certain kind of major state, I could essentially release that template into a template spec to make it available as a specific version. So it's not, well, do I use repos or do I use template specs? I can use these things together. So hey, I'll still track things in my repo. When I hit this major version, my pipeline may even create it. I can now have template specs available that people can go ahead and use. So it's not a case of, well, do I use my repo? Do I use template specs? You're probably going to end up using them together. Now, for the demos, I'm going to use PowerShell, but I can use anything. PowerShell and the Azure CLI are, I think, kind of the major investments, but I can use the REST API, I can use the portal to actually create all of these things. If I'm using the AZ module, I need version 5 of the AZ module to understand template specs. If I'm using the CLI, it's version 2.14.2. So let's actually just take a look at these and go through some kind of examples. Now, to start off, I'll jump over to looking at the code. We'll start off with a very basic storage account. Now, if you've seen my masterclass about infrastructure as code, this is the storage template. This is a very, very simple template. Once again, I'm not going through what is a template, but essentially you can see, well, we have parameters, sections, things I can pass in. So here I have a storage account type, and we also have a location. Both of them have default values, so I don't have to pass these in. Then we have a variable, so it creates a storage account name actually based on the resource group it's been written to. And then we have the resource itself. In this case, it's from the Microsoft.storage namespace, and it's a resource of type storage account. We pass some parameters into that, the location, the SKU, and the kind. And then we output the storage account name. So that's a super, super basic ARM template. Now, I could absolutely do this through the portal. So if I actually jump over to the portal, we can now actually see template specs. So I could just search for this, and we see template specs. Now, I've gone ahead and deleted them all, so I'm starting from a completely clean slate. And you can see I can import a template, so I'm going to pass it an ARM file, or just create one where I can actually paste in the JSON. So if I import a template, I can go and search, and what I can actually do from here is go to my repo, and I could find my particular template I want to use. And from within here, it will import that template. And then I have to give it a name. So I have to kind of give it a storage account, whatever that is. It goes into a resource group like any other resource. So I've actually created a resource group, template specs resource group. It gets stored in a location. I give it a description. I have to give it a version. For example, this is 1.0. This is up to you how you decide to do that. I can have change notes. So as I put in new versions, I should describe what I'm doing. That's going to make it easy for things like change logs to track. Remember, this is a release. It will show me the template that I've imported in that's going to create this template spec with. I could add tags and then review and create. So I can absolutely create these through the portal, but I'm not going to do that. What we're going to do is through this same kind of, I'm using VS Code, I've created kind of a little demo script. So what I've defined here is just the base location for where all my files are, and then a resource group I'm going to deploy to. Now here I'm using the new AZ template spec command. I have to give it a name. So this is, well, what is the name for that template spec? I have to give it a version, and then the resource group I'm storing the template in, then again a location, and then obviously, well, what is the template file? This is a very simple file, it's just one file. So if I run this command, it's going to go ahead and you can see it's finished. And if I now go back again and look at my template specs, well, there's my template spec. The parameters I passed it, I can go and look at it. Well, I can see there's my main template. I can look at the main template. Yep, there's that JSON. All good. I can see I've got my version 1. If there were multiple versions, I would see them. At this point, I could actually do a deployment. It will prompt me to pass in the parameters that I need, and I could now deploy this. So again, remember, it's just regular access control. At this point, as long as I add someone, so they have the reader role, that's the important part here, they just need reader, they would be able to use this template spec and deploy it. So that's at a bare minimum, I'm good there. But we'll take it a step further. So here I can actually look at, well, what are my various template specs I have. So we can see here, well, it's showing me I just have my basic template spec available in the resource group. I could get the detail about my template spec, so I can see a bit more about the creation time, last modified, all of those details. Now I want to use it. Now I actually want to go ahead and deploy that template spec. So to do that, what happened is that has an ID. Like all Azure resources, it has an ID. So the way we're going to use it is, well, let's get the ID of the template spec, because that resource has an ID. So I'm going to get the ID and then deploy that resource ID to my target. So let's jump back to the code. So what we're going to do is in this first command, we're just getting the ID and storing it to a variable. So we're saying, hey, get AZ template spec, the particular one we want. We're picking a particular version and we're getting the ID of that specific version. So I've gone ahead and got that ID. If we look at the ID, here I can see it's filled out that complete ID for the resource. So now I can just do that resource group deployment. Now again, my resource group name I'm deploying to is this RGSAV00724. I try and pick some random name because obviously I'm going to put this in GitHub and then everyone doesn't bother to change it. So they take over my resource group name and so my storage account fails. So I'm going to deploy to that resource group. So if we quickly look at that resource group, what we can see right now is it's empty. So we'll just run this code. We'll actually go ahead. I'm not passing it any parameters. So it's literally just going to use the default values. So if I just do new AZ resource group deployment, again, I'm passing it the ID of a template spec. So it's now going off and it's saying, okay, well, let's grab the template spec ID. The version 1 is what I've specified. And then let's deploy that resource. So now it's going to go ahead and in that target resource actually go and create my storage account as I've requested based on the attributes in there. For example, the SKU, the tier, etc. So let's go and look at where we are. So that's completed. So we go and check back into that detail. We can see, okay, well, it created this RG007 standard SA storage account. You can see that right now under the value. So we can see that passed. And now if we go to the portal, what we can actually see is if we refresh, this can take a little while sometimes, but hopefully it's quick enough. There we go. It's matching that particular configuration. We can see our LRS, our storage v2, and it picked the location of our resource group. So everything is good there. Now, for the next thing, we could actually still use that parameter file, that template spec, but this time we're going to use a parameter file. So once again, there's nothing special here. The point of a template, we don't want it to change. So our ARM template accepts parameters. And the reason it does that is the parameters will likely change between using different applications, using different environments. Hey, I want to deploy to dev, to UAT, to production. So the parameter file, if I want to use it, or I could just pass the parameters as part of the execution, we keep that separate because that's going to change between application and environment. But I can still use that. So as part of my deployment now, when I actually go ahead and do my deployment, yes, I specify the ID, the template spec ID I want to use, and I can pass parameters. I can pass those parameters interactively as part of the command line, or I could actually do it using a file. So that's what I'm going to show here. So in this next command, what we're going to do is I've actually got a template parameter file. Now, if we look at that parameter file, I'm changing the value to be standard GRS instead of LRS. Now, for the instance of time, I'm not going to keep running this every single go. So I'm just going to say what if. So that will tell me what would happen. So I'm still using the same template spec as we did before, but now I'm going to pass it a parameter file that will say, hey, make it GRS. So if I hit F8 on that, it's going to go and look at what is the reality, what's there today, which is an LRS storage account. Then it's looking at what's my desired state. My desired state now says, well, I want GRS. It's not going to do it because I'm saying what if, but it will show me, well, what's the difference between those things? And here it's telling me, hey, look, yeah, the SKU is going to change from standard LRS to standard GRS, which is what we would expect to see. Now, maybe over time, I want to change that JSON file. So if I go back to my storage account, one of the things I don't support is GZRS. So I might say, well, I want to support that. So I could take that line, and now we'll update this file, and I'll just add in GZRS. So that's 3 copies spread over different availability zones, plus an asynchronous replica to the paired region, where there's another 3 copies of it. So I'm going to save that. And now what we're going to do is create, again, a new template spec, but we're incrementing the version to version 1.1. So I'm just going to run it exactly the same as before. And now if we go back to the portal and we go back and look at our template specs, we still have our one template spec, but our current version is now 1.1. We can see that in here. I can select that to see my version 1.1. If we look at the template, we can now see it has this GZRS. So basically I'm releasing versions, making this available, and people can pick. People can say, well, actually, I want to stick with version 1.0. Hey, I want to go to 1.1. I can actually look at the versions. Hey, look, there's the 1.0 with no GZRS. Hey, here's the version 1.1 with the GZRS. So these are all available to me. So I'm actually getting that full capability to actually now have those multiple versions. So I can make changes. I can make changes in my repo. So again, kind of like my source tracking, I can still use my repo here. And then when I reach a certain stable point I want to make available to my users, either manually or maybe through a pipeline, hey, I'll go and create a new version of that. So I can actually go through and make that reality. So let's carry on going through our code. So back over here, and the portal's doing that strange thing where it puts something on the screen, so get rid of that. So what we're now going to do is think about a linked template. So that was a standalone template. One of the challenges you start facing with linked templates is, well, a linked template is where, hey, a template's calling another template. So if I think about, well, going over here, this template, maybe it's like a main master template, but I actually have a whole bunch of other templates that are almost like modules. Maybe one of those templates creates a storage account. Maybe one of them creates the networking. Maybe one of them creates an AKS cluster. And the link template, I basically, as the name suggests, I link to those templates. But the problem is we only send the Azure Resource Manager, which remember is the bit we're actually talking to, one template. So these files can't just be a local reference because it's not going to bring those up. They have to be publicly available. So what we typically had to do in the past is when we wanted to use a linked template, so we'll actually go ahead and open up a fairly generic one, is we'd have this template link and it would have to be a URI. Now that URI would have to be sent like a SAS, a shared access signature to a blob. So I'd upload my template to storage, to a blob, and then create a shared access signature that gives access to that blob. Or if it was in GitHub, you can get the raw URL to the GitHub repository. So what I have an example here is doing exactly that for GitHub. This is in my Azure Masterclass repo. So one way I would use it is the URI would be to the raw GitHub user content, all of this big long stuff, the storage account.json. But you can see the pain point. Either this has to be publicly available or I have to go around creating shared access signatures. But it works. If I go to my demo, you could see here, hey, I could actually pass my link to GitHub. I'll pass my parameter file. And so the actual file that's using this, again, if we go back to that GitHub, all it's deploying is from the Microsoft.resources namespace, a deployment. So it has no concept of a storage account deployment in this template. It's just calling another template. It has parameters, and those parameters will get passed to that linked template that I'm actually calling. So if I now run this command, again, I'm doing what if. So it's going to go to GitHub, pull down the template because it's a linked template. And then it's going to show me, well, what would it do? Again, I'm passing the parameters file, which is just local, to show I can always use a parameters file no matter what I do with these things, which is telling it to do a GRS. Doesn't matter where the template is, it's going to go and say, hey, look, it's LRS today. You're saying this is GRS. So we're going to have to change that type. So it's having to go to GitHub, pull down, and once again, hey, exactly as we would expect, it's telling me, hey, the SKU name is wrong. So we are going to go and change that SKU name. So you can kind of see that's a little bit painful. So what we are essentially having to do here is those linked templates are in that repo. So in this case, that storage account template is up here. And what we're having to do is in that link template, we have to do the URL of that file directly, the URI. So now when it deploys, it's actually having to go and pull it from there. So that's what we're doing within that. So it's a bit painful to have to kind of do that thing and maintain that. So what can we do better? Well, there's actually a number of different things we can do. But one of the things with template specs is we have a new type of kind of relative reference. So I can actually do this. I can just relative reference other files. And when I create my template spec, it will see, hey, you're referencing these other ARM templates. I'm going to pull those into the template spec as well. So I don't have to worry about that, hey, making it publicly accessible anymore. So that's phase one. So if we go and look at the code, what we can now do is, I'm now doing this linked local. I'm going to create a brand new template spec. Now, if I look at linked local, I'm doing really exactly the same thing, except instead of specifying a URI, it's the same Microsoft.resources deployment, but now it's this relative path, and I'm just pointing to storage account.json. The file we've been using the whole time, it's in the same folder as this. That's all I'm doing. I'm just saying, hey, don't worry about URI or anything else. It's in the same folder. It could be a child folder. I would just put in the relative path. So now what I'm going to do is actually create a template spec called linked storage account. And I'm going to pass it my storage account linked local file, the one that does that local reference. And we'll say go and create it. So it's finished already. If we go back to the portal now and look at our template specs, well, I can see there's a new one. Before I show that, let's look at the basic one again. It just has a main template file and there's no artifacts. If I now look at my linked file, well, I have my main template file that references this storage account.json. But notice I also have an artifact of a relative path. So if I now go and look at that, it has uploaded that JSON file as well that actually does the storage account deployment. So it's brought that in for me automatically. So the template spec is not just a file. If there are linked files, it will bring those in as well. So now from that user experience, and they're not worrying about, well, a blob and a GitHub raw location, it's just pulling all those things in for me. Again, think about a release. And at that point, I could now get the template spec of that linked storage account, and I could still deploy it. Now, again, I'm not doing a parameter file, so now it should just be, well, what you have deployed, remember that basic storage account, matches what is there. But notice I don't have to worry about the fact that there are multiple files. It is just pulling down whatever is needed internally in Azure. It's using the template spec. It sees, hey, you're deploying that linked storage account, and it references another file, but it's doing all the work for me. I'm not thinking about that at all. It just does the work. So in terms of now, if I have kind of those linked, and I think of those as modules, it's really taking away all that complexity. So again, I think about, I'll create releases. I still might use repos for my raw kind of ARM files. When I want to make them available, hey, I'll go and create a release with them all kind of packaged in to a particular version of a template spec. Now, I think probably the final combination would be, hey, I have my ARM template, and I actually have different template specs are the modules. So in my JSON file, I want to reference other template specs. So I've got template specs referencing essentially other template specs. And that's actually super easy to do as well. So if we go back to our code, so what we're going to do now is if we actually look at our linked template spec, all I have to do is essentially reference it. So I'm using a function. I'm getting the resource ID of something that's in, so I store them in the RG template spec. So I'm looking for a resource in the RG template specs resource group. It's in the same subscription, so I don't have to pass that in. And then I'm looking for type Microsoft Resources namespace, template specs versions, and then I'm getting the basic storage account, and then I want a particular version 1.0. So this is going to go and get the ID actually of that. So that's all this template is actually doing. So it's referencing another template spec. So to use that, I can just do a deployment. If I do a what if against that, we'll see, hey, it matches. Because again, remember, this is saying LRS. Well, LRS is there already. So I'm referencing from an ARM template I have a template spec. And it's saying no changes. Just to prove I can still use a parameter file, we'll run it again now, passing it a parameter file, exactly the same template, exactly the same referencing the template spec. But now I'm saying, hey, I want it to be GRS. So it's now going to go in and say, hey, your LRS today, you need to go and change it to GRS. So it's going to kind of do that for me. And there we can see, hey, yep, we would make this change. And finally, I could make that a template spec. I can create a template spec that references another template spec. So if I just run this, it's done. So now if I go and look at my template specs, I now have a spec linked storage account, which is just a main template. And that main template just references another template. So that's template specs. There's really nothing super complicated about them. It's literally just the ability that I can take my ARM file and store it as a first-class resource in Azure. So I can do resource-based access control. People just need read permissions to actually do deployment. I can version it. I can still pass parameter files when I use it. I can link to other files and it will get included in as part of the template spec. Or I can link to other template specs. All going to be fine. I'll probably still use repos as the base kind of management for my ARM files. And then when I reach a certain point, I want to make it usable to people. I'll then push it out as a delivery and stamp it with a certain version. And then again, anyone with read access can just go use it. I will upload kind of my little sample files to the Azure Masterclass repo. But I hope that was useful. And until next time, stay safe.